everyone. Hello. So, welcome to our ODE lecture. I just decided that, you know what, I'm going to post the lecture on LinkedIn too. Yeah, I mean, this is not meant to be a serious lecture, so don't worry about it. My finger hurts. Okay. Anyways, so we are going, oh shit. So, we are going to start with our, I don't know, is the third lecture? The only reason I'm just saying is it is because I've been doing this for quite a long time. Actually, after 2 days. So I kind of don't remember, but we are going to start off with chapter 2. So yes, chapter 2. So if you want to know about the chapter 1 lectures, you can go to the domain page, or I'm going to download them and post them on LinkedIn and on YouTube. Yeah, LinkedIn and YouTube. But this is chapter 2, and we are going to do the examples and stuff like that, not through, skimming through, not skimming through like the general points, like going through the notes and whatever. But what we're going to do is we're going to do two questions. And as we do two questions, I'm going to go along and I'm going to explain them like step by step, like what is going on. And so the chapter for this would be what's the chapter? Solution curves without a solution. This is chapter 2.1, solution curves without a solution. Can you guys see my screen? Can you guys hear me? Because let me just check if they can actually hear me. Because last time I did the recording, they couldn't hear me. I just want to check. Can you guys hear me? Hear me? Test, test, test. Can you guys hear me? Hear me? Test, test, test. All right. So you guys can hear me. Cool. All right. We're gonna go with our. So we're gonna go with our first question, which is we have dy by dx is equal to f of y, where f of y is equal to y minus 1, 3 minus y. So what the heck is this coffee? So we're told to find the critical points. What's critical points? Step 1, find critical points. Question: what is critical points? No, I'm not going to say any English or whatever. Oh, critical point is this, critical point is a blah 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 blah. Critical point occurs when dy by dx is equal to 0. Right? Critical point happens when dy by dx is equal to 0. And the only time you're going to have dy by dx, you're going to encounter something called critical point is when dy by dx is 0. Now, in this case, dy by dx is what? Is f of y from here. Dy by dx is f of y. And so now we're going to have dy by dx is equal to, f of y was what? F of y is equal to y minus 1, 3 minus y. So we're going to have 0. So we're going to have y minus 1, 3 minus y is equal to 0. Now, obviously, you can do that, right? If you can't, no worries. Y is equal to 0. Y minus 1 is equal to 0. Y is equal to 1. 3 minus y is equal to 0. 3 minus 0 is equal to y. Y is equal to 3. Right? So we have y equals 0, y equals 1, y equals 3. So these are our y values for when we can observe the critical point, right? So these are the y values for where we can observe. Actually, you know what? Let me do one thing. Sometimes you will not be able to see the, there you go. Now we're good. So you can see the screen, right? Yeah. I made it half because you will not be able to see the screen. I will be, I will not be able to see the screen because I'm using OBS now and the text doesn't work. The text may covered like the text over there. So we have y equals 0, y equals 1, y equals 3. And then now we're going to draw the graph. What we will do is draw the graph. So step 3, draw. Ugh, this coffee's. I don't think I put this much sweetener. So we have, obviously, we have y equals 0, we have y equals 1, we have y equals 3. So intervals. My interval 1, first of all, will be y is less than 0. We did, we're going to also encounter something called piecewise function, but y equals 0. I mean, not y equals 0, y less than 0. Y equals 0 is 0, obviously. Y less than 0. So we're going to have y, let's say, minus 1. Right? Now, if I take y is equal to minus 1, if I go back to this equation, y minus 1, 3 minus y, I have y minus 1, 3 minus, oh shit. So I'm going to have y minus 1, 3 minus y. So I'm going to have minus 1, minus 2, 4. So 2, 4, 8. So when y is less than 0, sorry. Oh, you guys can see. So when y is less than 0, so for any interval for y less than 0, it is positive. And if it is positive, we say that it will go arrow up. We're going to explain the arrow. We're going to draw a graph, and then I'm going to explain the arrow up, arrow down. Don't worry. Don't worry about it. So when y is equal to y is less than 0, it'll be positive. So which means it is going to go up. Now, interval 2, these intervals are important, and I'm going to explain in a second why. These intervals are very important because you need a graph for that, and within that graph, you'd actually have to draw the arrows for if for less than 0, where does it point? For within in between, where does it flow? And greater than that, where does it flow? And at the end of this lecture, I'm also going to explain where this is important. All right. So interval 2, if I have 0 less than y less than 1. Now, obviously, the only option we can go for y is a real value. I'm going to say y is equal to half. Right, so if I say y is equal to half, then I'm going to say half. What was the equation again? Y minus 1, 3 minus y. So y minus 1, 3 minus half, 2.5, 5 by 2. Minus 1/4, 5 by 2, so that is minus 5 by 8. So obviously it's a negative. It doesn't matter. Doesn't matter. So it's a negative. So for 0 less than y less than 1, it is always a, oh shit. 0 less than y less than 1, it is always a negative value, which means we're going to have arrow pointing downwards. Interval 3, for when 1, y, 3. Obviously you're going to go for 2, right? Because the only value you're going to, I mean, you can go for 2.1, you can go for 2.2, you can go for 2.3. Nobody's stopping you, right? But in general, common sense, you're going to go for 2. So if y is equal to 2, then I'm going to have 2, y minus 1, 1, 3 minus 2, 1. So 1, 1, 2, 2. Positive, right? So we have a positive, we have a negative, we have a positive. And then obviously you'll also have y greater than 3. And y greater than 3 is 4. Then if I'm going to have 4, I'm going to have 3, I'm going to have minus 1, so that is minus 12, so that is negative. So what I have is a plus, a minus, a plus, a minus. Now remember remember I spoke about the graph? Well, you can consider it a graph. The only reason I stated this as a graph, I mean, this is not necessary. The X line is not necessary, but I'm just drawing the X line, it's fine. So I'm going to have y is equal to 0. I'm going to have y is equal to 1. I'm going to have y is equal to 3. And I'm going to draw that in yellow, actually lime green. So y less than 0, what did we say? Y less than 0 was positive. For any sections here, less than 0, I'm going to have arrow going upwards. Why did I say that my arrows will go upwards? Because when I solved, when I selected -1, I got 8, right? If I were to pick -2, I'm going to get a positive value. If I get -3, I'm going to get a positive value. -4 positive, -5 positive, -6 positive, so on and so on and so forth. And because anything less than 0, I'm going to get a positive value, my arrow will go upwards. So that is for less than 0. Now anything, my bad, my bad. Anything in between 0 and 1. Anything in between 0 and 1. So anything in between 0 and 1, we know it will be a negative. So I'm going to have half going down, right? So I'm going to have half going down. Actually, I maybe overlap 1, but that's completely fine. And then 1 to 3, I may have overlapped a bit. Now 1 to 3, I mean 1 less than y less than 3. And we also know that it is a positive, because when we selected 2, we got 2, 1, 1, right? We got 2, 1, 1, which is 2. It's a positive value. Now I can go for 2.1, I can go for 2.2, 2.3, 2.4, 2.5, it doesn't matter. At the end of the day, it's going to go up, right? It is going to go upwards. And anything greater than 3, it is going to go downward, right? We have up, down, like that, right? So it's going to go up, down, up, down. Now, at y equals 0, now to check the um, stability, like I'm not stability, equilibrium for each of those, because your key values are what? Y is equal to 0, y is equal to 1, y is equal to 3, right? If your um, below and above touch, so if below is going down and above is going up, that is unstable. So think of it like, okay, I cannot do that shit. I cannot do that shit. But if you go down, so if the below actually goes below and above actually goes above, I cannot do that shit. I'm gonna get banned. So if below goes below and above goes above, that's unstable. So over here, 0 to 1 and 1 to 3, I'm going to pick that for equilibrium y is equal to 1. Now, if I look at y is equal to 0, if I look at y is equal to 0, I'm going to have two things. I'm going to have y less than 0, and I'm also going to have 0, 1. Now, y less than 0 is going upwards, right? Y less than 0 is going upwards. 0 less than y less than 1 is going downwards. But because the ones below are going above and the ones above are going below, it's going to connect. It's going to intersect at some point. And because it intersects, that y is equal to 0 is stable. Y is equal to 0 is stable. Khalas. Y is equal to 1, I'm going to have two things. 0, y1, and 1, y3. Now 0, y1, which is the below part, right? The above for previous one is the below for next one. The above for previous one is the below for next one. If my above, which is 0 less than y less than 1, we know that it is going down. So that same going down, I'm going to consider that at y is equal to 1. So this is going down, right? This is going down, but this is going up, which means my below, my below y equal 1 is going down. My above y equal 1 is going up. But because below is going below and above is going above, they do not intersect or they do not connect. And that ends up unstable. So my y equal 1 is unstable. Why is it unstable? Again, the only reason it is unstable is because the ones below are going below and the ones above are going above. On y equals 0, we had the below going above and the above coming below. So it's like saying, this, I mean, I don't know if you understood, but if you didn't understand, that's fine. It's like rain falling and the water pressure going up. So at some, like, think of it that way. So think of like something from above coming down and something from below going up. It's like, if you look at Naruto episode 400, I don't know, when Sasuke was going down, Naruto was going up. So you saw that they connected, right? Think of it like that. So because they connected, that's stable. Obviously, both of them lost their arms. Definitely, both of them lost their dominant arms, but either or, it connected. The ones going below, it's obviously going below, and the ones going above, that is unstable, right? Now, y equals 1, unstable. Y equals 3, we're going to have 1, y, 3, and y3. 1 less than y less than 3 is going upwards, right? So this is your below. The above for previous is the below for next. So this is going upward. Up, 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 up. So so below y3, y equals 3 is going above. And above y equals 3, above y equals 3 is going below. Right? And because the below one is going above and the above one is going below, they're going to connect. So which means y is equal to 3, that is stable. Right? So we have y equals 0, y equals 1, y equals 3 being stable. Oh shit. Stable, unstable, and stable. Cool? Right? Now we're going to draw the graph for f is equal to y. So if I have f equals f of y, then I'm going to have y minus 1, y minus 3. Now obviously the highest power becomes the cubic. So more specifically, the minus y cube. Because if I were to look at it, so I have y, I'm going to do that first. Y square minus 4y plus 3. I'm going to have y cube minus 4y square plus 3. Well, no, it's y cube. The highest power is y cube. Y cube is the highest power. Is it? Y minus 1, y minus 3. Y square minus 3y minus y plus 3. Yeah, y cube is the highest. And if I were to draw the graph for it, remember we drew the arrows? The above, below, whatever. And remember, I already said the answer for the sine wave. Anything less than 0 is going to go upwards. It's going to go up, 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 up. And then it's going to touch at 1. Let's consider this as 1. Let's say. Right? No, not, sorry, not that. Oh, come on. This one. So 0, 1, 3. Actually, This will be y, and that's not x. Oh, come on. So this will be y, and this will be f of y. So this is y, this is f of y. And when y is equal to 0, we know from less than 0 it's going to go upwards. So we're going to go up, 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 up. Oh, it's not working? Oh, come on. We're going to go up, 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 up. And then it's going to touch 1. Now we're going to go down. Yeah, we're going to go down. Oh, no. Our 0. So first of all, we're going to go to 0. This is less than 0. Wait, 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 wait. This is less than 0. It's going to go up, 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 up. Now it's touching 0. Now so this section here is less than 0. That is going up. So this section here is less than 0. That is going up. Now we'll enter the 0 less than y less than 1 region. So this is the 0 less than y less than 1 region. And what was the point that we selected? Half. So we're going to go half. Let's say this is half. And what do we know about 0 less than y less than 1? It's going to go down, right? We're going to go down. So 0 less than y less than 1 region is over. Correct? Correct? Now y, sorry, 1 less than y less than 3. We are now entering a region for 1 less than y less than 3. So this is the region that we are going to enter. And we know that 1 less than y less than 3, we selected 2, and it's going to go up. So we're going to go upwards now. It's going to be a little steeper. Let's consider that as 2. So now we have entered the region. Cool. And it's going to go up. Now, y greater than 3. Y greater than 3 is going downwards. Correct? Y greater than 3 is going downwards. And because now we're going to enter the y greater than 3, we're going to try to widespread it. We're going to go there. So we're going to go, I mean, we can keep going. We can keep going all the way to the side. We can do that. But this is how the graph will look like. Right? So this is how the graph will look like. Cool? All right. Is there anything else needed? Let me just check. So yeah, if I were to draw the line graph, I can draw the line graph. That is completely fine. I'm gonna have that, 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 and then there. It's like kind of like a stock market graph, right? Right? It's like kind of like a stock market graph. Cool. We can check the concavity. So now we're going to check the concavity. The way you can check the concavity is by differentiating the I mean not differentiating, second order differentiating it. So by y prime prime. Now obviously dy by dx is f of y, and f of y being y minus 1, y minus 3. And so my dy by dx is y minus 1, y minus 3, where dy by dx is y square 4y 3, which is dy by dx is y cube minus 4y square plus 3y. If I differentiate this guy, oh shit. So d square y by dx square is just the first derivative for the first derivative, right? So second derivative for the original equation, first derivative for the first derivative. That's the second derivative. So we're going to have 3y square minus 8y plus 3. Because obviously dy by dx of y cube is 3y square, dy by dx of 4y square is 8y, dy by dx of 3y is 3. Cool? Cool? And so that is your d square y by dx square. And also we need to check the, because in concavity, y prime prime is equal to 0. So which means we're going to have 3y square minus 8y plus 3 is equal to 0. Right? Right? This will be the equation. And now we're going to solve the quadratic. We can. 3y square minus 8y plus 3. What was that equation? Minus b plus minus square root of b square minus 4ac divided by 2a. So you're going to have 8, 64 minus 36 is what? 64 minus 36 is what? 64, 36, 28. We're going to have 8 plus minus square root 28 by 6. And 28 is 28. Or square root of 28. Whatever. Whatever. So your concavity will change at 8 plus square root 28 by 6 and 8 minus square root 28 by 6. So your concavity changes, so there will be inflection points. So that's where the inflection points exist. The inflection points will exist at here and here. And the only way we solve the inflection point is by second differentiating it. So what so far we did was we given the first order differential equation as f of y. We saw the f of y equation. We want to, oh, my iPad is lagging. So we will find the critical points. To find the critical points, we're going to consider the dy by dx is equal to 0. And so when we consider the dy by dx is equal to 0, only then we can find the y, all the three y's, right? So we found y is equal to 0, y is equal to 1, y is equal to 3. Okay, my iPad is actually shit. We're going to have y is equal to 1, y is equal to 0, y is equal to 1, y is equal to 3. That's our critical point, not inflection point, critical point. And to observe how the graph will look like, you'd first have to get what will happen, the behavior of the graph at y less than 0, the behavior of the graph at for y at 1 less than y less than 3, and then y greater than 3. So less than 0, I'm sorry, I'm missing something. So you need to get y less than 0 because you want to get the behavior for 0. And on 0, you have two things. On y is equal to 0, you have two things. You have y less than 0 and you have 0, y, 1, right? Y equals 1, you have 0, y, 1 and 1, y, 3. And obviously y is equal to 3, you have 1, y, 3 and y, 3. So you need to get the behavior for this. You need to get the behavior for this. The same behavior for this, like again, the bottom for previous one is the top for first one. The bottom for previous one is the top for first one. So these two are same, right? So in here, we need to find y less than 0. These two are same. Then these two are same. And then you need to get y greater than 3. And then when you see the values increase and then decrease and then increase and then decrease, so eventually you can draw the graph because obviously plot out the arrows, right? So when you look at the arrows here, it's going up, 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 and then down, 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 and then up, 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 and then down, 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 down. And then when you draw the graph, you're gonna have a graph going up. You're gonna have graph going up until your selected value. So in this case, y was half. So it's going to go until half, go down, go up again, then go all the way down. So that's how you find your graph, right? So then you're going to measure whether it's unstable or not. To if it stay if the above goes below, below goes above, that's stable. If above goes above, below goes below, that is unstable. So we have stable, unstable, stable. And to find the inflection point, we have to differentiate the first derivative. So our first derivative was y minus 1, y minus 3. We did the equations. We have y cubed minus 4, y cubed minus 4y squared plus 3y. And then we we did the differentiation. For the first order differentiation, we got 3y squared minus 8y plus 3. And then we got the quadratic equation. We solved the quadratic equation, and these are our inflection points. I hope you understood. I hope you really, really understood. If you don't understand, you're free to email, you're free to comment. It's on LinkedIn, so you're free to comment. You're free to insult me if you want to insult me. So you're literally free to say anything. All right. I hope you understood. We'll move to the next one.